Hey guys, and welcome back to another great episode of Damos in the Class. I hope you guys are enjoying your summer break and also the holiday that just passed. So, yes, we've been missing in action, but now we're back because, like we like to work hard, we need to play hard too. So, now it's time to get back to some work, and today we're going to be focusing on fractions. Yep, again. There's a lot to fractions, so we're going to want to dive in one more time, and then we're going to move on to different parts, and we will come back to fractions later on. But I do want to end up going over the last few things that we started working on, so then we can move topics completely. All right, guys, so let's get ready to start today's lesson. Today's aim, subtracting mixed numbers. Decomposing and composing mixed numbers and improper fractions. Alright, so for our first practice 3 problems, we have 6 and 7 over 8, take away 2 and 2 over 8. Then we have 4, 9 over 10, take away 1 and 5 over 10. And then our last practice problem, we'll do 9 and 10 over 12, take away 2 and 4 over 12. All right, so we're going to start this problem just like all our other problems. And the mixed numbers, which are a whole number and a fraction, we always start with our fraction side first. So, like we've been doing, we see what is our denominator?
8.
All right, so 8 is going to be our denominator. And then we are going to go in and circle our numerators, and that creates our number sentence. What is that number sentence, Jamia?
7 take away 2.
Good job. So 7 take away 2, and what's the answer?
5.
All right. So that's the answer for our numerator, and we're going to put that right here on top. So your fraction side is done, and you should have an answer of 5 over 8. So now we're going to look at our whole number side, and just as it says, 6 take away 2. That's exactly what we're doing. We're at 2. We're counting up to 6. So that's 3, 4. Come on, guys, count with me. 5, 6. So the answer is 4. The answer to the problem would be 4 and 5 over 8. All right, so moving on to number 2, we have 4 and 9 over 10, take away 1 and 5 over 10. We're going to do the exact same thing, so we starting with our fraction side. And what is our denominator going to be, Jamia?
The 10s.
All right, 10 is our denominator. And we go in, as you know, you circle. I got my equation is 9 take away 5. What's my answer, Jamia?
Equals 4.
All right. So our numerator is 4. So guys, before we move on to the whole side, which is what we normally would do, I hope someone is noticing. Do we notice what a 4 and a 0 gets us? What kind of numbers are those?
Even numbers.
Exactly. So remember, even numbers, we must reduce. So, how can we make 4? We could do 1 times 4 to get us 4. And we could do 2 times 2 to get us 4. We know we cannot use the 1, so our factors of 4 are really only 2. So now we're going to find the factors of 10. We got 1 times 10 will give you 10. And we have 2 times 5 will give us 10. We know we don't use our 1, so our factors of 10 are 2 and 5. So what do they share? The 4 and the 10, what do they share? What numbers do they share in a factor?
2s.
All right, so we're going to use the 2. They both share our 2, as you can see. So we're going to divide by 2 over 2. Now, we know that the multiplication is the opposite. So if we have 2, 2 times what gives us 4? The 2. And the same thing with 2 times what? It gave us 10, the 5. So our new fraction should be 2 over 5. All right, so now we're just going to look at our whole number side. We have 4, take away 1. And what's that answer?
3.
All right, so now we have an answer of 3 and 2 over 5. 4 over 10 to 2 over 5. But I like to write it all together, my last final answer. But either one is acceptable. And if you leave it like this, then you can just write it like this. But your teacher or whoever's grading it, they would definitely understand what you're doing. And give you total credit, sometimes extra credit, depending on what they were looking for, who your teacher is, what kind of test it is. Alright guys, so we're just going to go right in. I'm sure everyone by this time knows that our denominator is the 12, that we circled our numerator that gave us a 10 take away 4 equals 6. We put our 6 over here, but we should also realize that these are both 6 is even, 2 is even. So if you didn't know, 1 times 6 and 2 times 3, 1 times 12, 2 times 6, and 3 times 4 is how we get 12. And if you look and see, we do not use our 1s, but they do share the 2. So we're not going to take the 2 because they also share a 6. And the GCF, the G stands for greater. So 6 would be the highest one. So we would divide by 6 over 6. We only could do that 1 time. And here we can do that 2 times. Because 2 times 6 is 12. And 1 times 6 is 6. So you will have an answer now of 1/2. So now we're just going to move right along over to our whole number side. And we have another number sentence of 9 take away 2. That's going to give us 7. So our complete answer will be 7 and 1/2. Alright guys, so now we got 3 more practice problems. We got 5 take away 2 and 3 over 6. Our second one is going to be 7 and 5 over 10, take away 1 and 9 over 10. And our last practice one is going to be 8, take away 2 and 1 over 4. So starting with the first one, I know you guys already can notice that there is no fraction. There isn't. So when that happens and there's just a whole number that needs to be subtracted from a mixed number, we need a fraction. So how do we get that fraction? We have to then go over to our whole number and actually borrow a whole one. So that's what we're going to do. So that's exactly what we're going to do. We're going to come over to the 5. We are going to cross that out. And then we are going to put a 4. So now that we put our 4, that's actually taking 1. And as we know, or should know, or we might not know, that 6 over 6 will be our representation of the 1 that we borrowed. Why? Because our denominator is 6, so we need this denominator to also match. And any denominator and numerator that are the same, they are a total of a whole number 1. So now our borrowed 1, we have our 4 here, and this 6 over 6 makes our whole 5. So now we can actually go ahead and start this problem. So we're going to do it like any other problem, and we're going to now start our fraction side first. So as we see, our denominators are the 6, so we keep those as the same. We circle our numerator sentence. We write our numerator sentence as 6 take away 3. We get an answer of 3. We put that 3 over 6. Because you guys, I know y'all multiplication. Everyone knows that we can get 6 with 1 times 6 and 2 times 3. So with that being said, we can then go in and divide by, because the only way we can get 3 is 1 times 3. So therefore, we can go in and divide by our greatest common factor. We can't use 1, it would be 3. So now it's 3 over 3 is what we divide that by. And if we have 3 and we divided 3, we only can do that 1 time. And if we have 6 and we divide 3, as we see in the opposite, we only can do that 2 times. So that would then get you a new fraction of 1/2. Alright guys, so just to finish the problem, we do it like normal. We go to our whole numbers. We have 4 take away 2. That's going to leave us with 2. So our answer should be 2 and 1/2. Alright guys, so now we're looking at our second problem. We have 7 and 5 over 10. Take away 1 and 9 over 10. We're going to go ahead. We see we have our denominators of 10. We circled our numerator. So now, our sentence would be exactly how it is. However, 5 we cannot take 9 from. If you have 5, you cannot subtract to get a positive number. So therefore, this is going to stop us immediately, and we have to go in and borrow. So we're going to go to that 7, and we're going to make that now a 6. Put that 6 right over top. And the same thing like we said, the same amount of numerator and denominator makes it equal 1. So our denominator is a 10. So when we borrow our 1, we are now going to be adding, because we do have a fraction here. So we will be adding 10 over 10, because that is our representation of our 1. This part can get a little tricky, but please pay attention. So now we're going to do this part of the problem like we know to do. We have like denominators, which makes us keep our denominator of 10. So that does not change. We have our 10. Nothing will change. We will then circle our numerator sentence. Now we have a sentence of, I'm still writing always my bigger number first. So I have 10 plus 5. So guys, I know you guys know how to, alright, what's that going to be? 15?
15.
Alright, good job. So we have an answer of 15. That's what comes up here. It's not down in our answer yet. We did not solve the answer. We are still up here trying to get enough so we can start the problem, guys. So we have 15 over 10. Okay? So that is the numerator now that we need to circle to be into this sentence. So now we circle our numerator and we have our 9. So to get this answer, we need 15 take away the 9. And that's what we're going to write. 15 take away 9 equals. So you're at 9.
10, 11, 12, 13, 14, 15.
How much?
6.
Good job. So we get an answer of 6. That is what is going to be up on top as our numerator thus far. Still not the total answer, guys. Why? Because the 6 and the 0 are what kind of numbers?
Even.
Therefore, we need to reduce. And we know 1 times 6, 2 times 3 is the only way to get our 6's. We know 1 times 10 and 2 times 5 will be the only way to get our 10. Looking at that, we can see clearly that they only share 2's. So we're going to divide by 2 over 2. Knowing that division is the opposite of multiplication, 2 times 3 is what gave us the 6. 2 times 5 is what gave us the 10. So now we should have a new fraction of 3 over 5. I hope everyone's with me. I know you guys are. Great job. Alright guys, so now we're just going to finish the problem out with our whole number side, and that is going to be 6 take away 1, and that's at 1 we count up to 6.
We got 5.
We got 5 left. So therefore our answer should be 5 and 3 over 5, guys. Great job. Alright guys, so moving on to our last practice problem. I'm not going to say last, but last for this one, for these set. So we have 8, and we have take away 2 and 1/4. So guys, I know you already see again, we do not have our fraction. So what do we need to do if we don't have a fraction, Jamil?
Borrow.
Alright, so we're going to go ahead and we're going to borrow from the 8. We're going to cross that out. And we're going to put a 7 right on top. And like we said, we need a fraction. So how do we get our fraction? We look at what our denominator is. Our denominator is a 4. So we go ahead and make our new denominator a 4. And we put the same number on top to make that a whole. So that will represent our 7, and this one here makes our 8. So now we can go ahead and start this problem as normal. So we have our denominator set at 4. We circle. We have our 4 take away 1 equals 3. And we now have our fraction of 3/4. Then we go into our whole number side. We have 7 take away 2. And that's going to leave us with 5. So we have now an answer of 5 3/4. Alright guys, so we're going to look at these 4 problems. We have, well, they're not actually problems, they are mixed numbers. So we have our first one, we have 2 and 3 over 8. Our second one is 1 and 5 over 7. Our third one is 3 and 4 over 5. And our fourth one is 4 and 7 over 12. So we're going to go ahead, we're going to look at this first one, which is 2 and 3 over 8. And what we first want to do is we want to go into decomposing and composing of this fraction. So now, I will hope you guys remember from the last time, decomposing would be to take it apart, and composing would be to put it together in different ways. So now, we're going to see how we could compose this fraction in 2 different ways. So we're going to go ahead, that composing should probably be the easiest way, which would be adding them. So now we have 2 is our whole number and 3/8. So I'm going to show one way in the diagram of how this would look. So speaking of 2 wholes, that means we have 2 whole shapes. Actually, give me 1 second. And bear with me guys, because I'll be freehanding it. But, so I want to make sure that you get this. So let me get with my fractions first. So I'm going to split this in 2. And I'm going to split this in 4. I'm going to split this in 6. And I'm going to split that in 8. So now I have 8 here. Okay? So I'm going to do that 3 times, guys. Give me 1 more moment. So I'm going here. Let's split that in half. Let's split that again. Let's split that on one side. Let's split that on the other. And I'm going to do that 1 more time on this side. Alright, so let's split this in half, this in half, this in half, and that in half. So now, if you see each side has 1, 2, 3, 4, 5, 6, 7, 8. Why? Because our denominator is 8. So, in order to represent our whole, remember, they need to be all shaded in. So this is our first hole, and this would be our second. And this is going to represent the number 2 in our mixed number. 2 whole pieces. And this one here is going to represent our fraction. So we have a total of 8, that's what that means, but we only have 3 of those shaded. Alright, so now that we have our diagram drawn, we are going to represent these into fractions. So like we said, these are the total pieces, which are 8. 1, 2, 3, 4, 5, 6, 7, 8. So our denominator will be our 8. And they're all shaded in, so then our top number will be the 8. Again, that's how we get it to be a whole. Plus another 8 over 8. Plus our 3 over 8. And that should equal, and that will equal our 2 and 3 over 8. Alright, so now we're just going to rearrange so we can find another way to represent the same mixed number. So I'm going to go ahead and I'm going to use another whole diagram. To give you my 8, so that's going to be another whole. And from that whole, I might also think I'm going to take me a part of this fraction. So therefore, I need another box drawn. And I'm going to just take 1/8 with me. So over here, this represents 1 whole, which is 8 over 8, plus 1 over 8, right? And then I still have another whole I didn't use yet. So I'm going to use that one too. But actually, guys, I just want you to understand that rearranging them is just all we're doing. And they could be any way you like. So we had 3 fractions out of this 8 here. I took one of them there. So I'm going to put another one over here with this part. So now I have plus another 8 over 8 plus another 1 over 8. But I still got 1/8 left that I didn't use. I've just got to make sure we use everything. So now I'm just going to draw me another one. And that's going to give me my last 1 over 8. And then we're just going to count this up, guys. And it should add up to our 2 wholes and 3 over 8. So, as you see, we have 1 whole, which is 8 over 8. But if you do the math, it'll still be the same thing. So how about we just do the math? So we see how our denominators are all 8s. So that's going to give us a denominator of 8. Then we're going to go in. We're going to circle all our numerators, guys. It's going to be a long number sentence, but I'm sure you can handle it. And we're just going to count this out loud. So if we're at 8, we go up 1 time, then we'll be at what? 9. Right. And then if we're at 9, we're going to go up 8 times from 9, guys. So we're at 9. Let's count. 10, 11, 12, 13, 14, 15, 16, 17, 17. 8 times. So we stopped at 17. So that's where we at this one, 17. Now we got one more. So if we at 17, we count up 1 time, that's 18. Then we count up 1 more, that's 19. So 19 over 8. that comes out to be an improper fraction. But guess what, guys? We don't leave it there. So we know that we're going to put that 19 in the house. We're going to put that 8 on the outside. And then we're going to go ahead and solve. So we know that 8 is bigger than 1, right? So we cannot divide into 1. But we can divide into 19 when you put those together. So you always want to say, whatever your divisor is on the outside, what is that times 2? So we just go and say 8 times 2. What's 8 times 2, Jamir? What's 8 times 2?
16.
16, okay. We're getting close. We need to get as close as we can, or if not, to 19, right? So do we think we're close enough, or should we try for 8 times 3?
We just have to say 8 times 3.
All right, so what's 8 times 3 then, Jamir?
They're going to say 24, but it's too big, so we have to do 8 times 2.
All right, that's right. So 8 times 3 is 24. Great job. And we're going to go ahead and use the 2 because we went past 19. So 8 times 2 is 16, guys. So if you're at 16, count up to 19.
17, 18, 19.
And how much is that?
3.
All right. And that's where we get our 3 from our remainder. But because we're working fractions, our remainder becomes our numerator and our denominator stays the 8. And now it is 2 3/8. To let you know that you have created or recreated the same initial mixed number that you started out with. So this diagram would work also for composing 2 3/8. Alright guys, so now we're going to look at 1 5/7. So we're going to do the same thing. First I am going to draw this out so you can see what this looks like so we can then decompose it. So we have one whole and it's 7 parts in this one. Cute. So let's see how we do that. So we see how to do 8, right? So what I'm going to do is do that from a 7. Yes. And we're going to still split it in half. Hold up. Let me take y'all. This need to be at my half mark. I told you I'm doing this on the fly. Alright, so then I'm going to keep my half going. Boom. And we're going to, this is the second half. So we're going to do a half. Then we're going to, wait, no. Hold on. Let me do it over. In my head, I see it. Let me get it right out here. Alright, so boom. Bam. Right? And then we're going to cut off one of these. That's all I wanted to do was cut that one out. Alright, so there's our 7. So we only had to do that one time. No, we got to do it 2 times. So I got my hole. And then I'm going to have my fraction side. Do it the same way. Cut off my last piece. Give me 7. And we have a hole. So that needs to be all shaded. And then 5 of these. 2, 3, 4, and 5. So there is our hole. And there's our 5/7. So we need to have this at 7/7 because our pieces are 7 plus 5/7. That would be our way. Or we can rearrange it a different way. Our total bottom needs to be 7. So that would be one way. So we can do it how other way. We have these empty spaces so we could just well, that would be the same thing if we moved it that way. So what's another way can we compose? We can split it up however way. The bottom line is we see we need to have 12, right? So our Denominator definitely has to stay at 7. So we can also change this to be, well, I'm going to do it with a diagram so you don't be confused. So let me draw another diagram. Now, I haven't decided how many I want to color, guys. Maybe I'll do 3. So let's see how that works. First, let's get the diagram together. Put it in our 7s. So let's in our 7s now. And now we can shade in 1, 2, 3. I'm just shading 3. And then I'm going to come over here. Oops. I'm going to make another one. Right? Then I'm going to split this one off. And on this one, guys, I'm going to shade in 4. And then this one, guys, and all I'm doing is making a rectangle. I'm splitting it in half. I'm splitting, let me make it a little better. So you can use 2, actually I'm going to show you in Jamia's book in just a moment how you can make these shapes on notebook paper. And that will be a lot easier. Just let me finish this and I'll show you that. So now, we got that. And I'm just gonna do 2. And then I'm gonna do one more. Split this in half, and in half, and in half, and in half. I'm gonna cut off this last one here. And these, I'm just do 3. I'm gonna see if my math is right, guys. Okay, so now we're just gonna substitute these diagrams into fractions. So this, we have 7 as our denominator, and we only have 3 shaded in. So that's our 3 7s. Then we have the same here, 7 as a denominator, and we have 4 shaded in. Plus, we have another 7 as our denominator, and we have 2 shaded in. And the last one, we have a 7, and we have 3 shaded in. And let's just see, guys, what we're going to get. So we know we have 7 as our denominator. We circle our numerator so we get our sentence. Okay, guys? So let's just count together. We are at 3. We are going to count up 4 times. So we're at 3. So we're going to go 4 times. So 4, 5, 6, 7. So we're at 7, guys. Now we got 2 more. So we're at 7. We're going to count up 2 times.
8, 9.
All right. So now we're at 9. We're going to count up 3 times.
10, 11, 12.
All right, guys. So we get a 12 over here. And so we know that is an improper fraction. So we're going to go ahead and put that in the house. And our 7, I usually never change it, but I don't want to confuse you. So I'll put my 12 and 7 over here. Put my 7 out there where you can see. And let me raise it up just a little bit so I can have a little bit more room. And now we know 7 is too big to go into 1, but it can go into 12. And we already know 7 times 2 is what?
7 times 2 is 14.
Ah, good job. 14. So 14, we passed 12, so we only could do 1. So 1 times 7 is how much?
7.
So we're going to put that underneath the 12 with a subtraction and an equal. We're at 7. We're going to count up to 12.
8, 9, 10, 11, 12.
And we're going to get an answer of how much?
5.
All right. And that remainder 5 becomes our numerator. And our denominator is a 7. So we have now recreated 2 different ways of getting 1 and 5 over 7. All right, guys, so we're going to show you how to make it in your notebook. So, Jamie, go ahead. Drop down 2 times. Then go over. All the way over. And stop. Then come up. And go all the way back over. Close it off. Now find where the middle point is at. Go through the blue lines. Now, make half on that side and half on the other side. And take your eraser, the big eraser, and just cut off that last box. Just a little bit right here. Yep, and that's going to give you your 7 pieces. Just like that. Great job. Alright guys, so we are going to practice this for 2 more times. This will be the 3rd, and we got 1 more to do. So the same thing, we got 3 and 4/5, and how can we create that? Alright, so I'm just going to make us a little bar. 2, 3, 4, and we're going to split them in 5s. And we're going to do that 3 times. 1, 2, 3, 4. And we're just going to do that. So, how to make that in your book. Let me make this look a little bit more symmetry. How to do that in your book is just take your first 2 blue lines, follow those, make a nice little square, a nice little rectangle, and just cut you 4 lines through to get it as best as you can to create 5 parts. Alright, so I definitely need to do that still one more time. So let me just do it right here, and that will be for my fraction part. Alright guys, so to create our holes, they need to all be shaded in. That's what makes them holes. So we're just going to go back in and shade those in. And those will be our holes. Which this is not going to work right here, guys. I got to move it, I'm sorry. Because, I'm going to throw it down here. Because I need to be able to make room for my number sentence. Right here, guys. So I'll put it over here. And then we have 4/5. So it's 1, 2, 3, and 4. So that's how we need it to look, so we can understand that each are our holes, and our denominator is 5. As we see, we have 5 pieces total, 5 pieces shaded, plus 5 pieces total, 5 pieces shaded, plus 5 pieces total, 5 pieces shaded, plus 5 pieces total, 4 pieces shaded. And that's how the first one is. And we can do that math to see what that gets us. Which we would circle, circle, and circle, and circle. So now we're counting by 5s. So we have 5 and 5. So we 5.
5, 10, 15, 20.
Stop. You only see 3 5s. It's okay. Stop. So it's count again.
5, 10, 15.
All right. Now we're going to add in 4. You're at 15. Count up 4. You're at 15. Count up
16, 17, 18, 19, 19.
All right. So we got 19 over 5. And we know that is an improper fraction, meaning that the numerator is larger than the denominator. So we're going to put 19 in the house, 5 on the outside. And we're going to now find how many groups of 5 does it take us to get to 19. 5 times 2 is what, Jamir?
5 times 2 is 10.
All right. 5 times 3 is what, Jamir?
15.
All right. And 5 times 4, Jamir, is?
20.
All right. So 20 is too far. So we can only use 3 groups. And we do the multiplication. 5 times 3 is the 15. We put that underneath our 19. We subtract sign and an equal. You're at 15. All you have to do is count up to 19.
16, 17, 18, 19, 4.
All right, so we get 4 as our remainder. That becomes our numerator, and 5 is our denominator, which gets us back to the 3 and 4/5 like we were trying to get to. This is our first way. We will then do another way. All right, for our second way, I am going to put my bars back so I can decide how I want to make this, guys. Alright, so I am going to shade in all my parts from this first one. And that will make that 5 over 5 plus I will shade in another whole one. And that would give me another 5 over 5. Then here, guys, I'm going to shade in I'm going to shade in 3 over 5. And then here, I'm going to shade in 3 over 5. And here, I'm going to shade in 3 over 5. Alright, guys, and so let's see what we come up with. And hopefully we have decomposed our fraction for the second way. So we're going to, again, always keep our denominator, circle our numerators for our sentence. Alright, and then we're going to go ahead and we're going to count. So we have 5 and 5, so we have 5 and 5 is how much?
5, 10.
Right, 10 plus 3. We're at 10, we need to add 3 more.
11, 12, 13.
You add 13, count up another 3.
14, 15, 16.
You add 16, count up another 3.
17, 18, 19.
Oh, go figure, 19. It's the same number we just got the last time. Remember, guys? So, really quick, 19 went in the house. 5 is on the outside. 3 groups got us there. 5 times 3 is 15. Take away 19, take away 15 gives us 4 with our remainder, 4 as our numerator and 5 as our denominator, giving us 3 4/5. This is the second way that you can depose the mixed number of 3 4/5. Alright, for our last problem, we have 4 and 7 over 12. So I'm going to go in and draw a diagram to let us see what that looks like. So since we've been doing rectangles, we're going to keep it going. And we're going to split it in half. I'm going to split it in half. And then I'm going to split it in half. And then I'm going to split it in half. That ain't what I want to do. Sorry, guys. That's not how I'm going to get what I need. So I need to do this. Is what I need to do. Now I need my middle. And then I need 1. And then I need another 1. And then I need 2 more, y'all. So we're going to extend this out for this one. And then this one. Now we need that doubled. Alright, so we need that a lot of times. So you see the shape. I'm going to erase it one more time because I need 4. So I'm going to need this to be a little bit smaller so I can fit it. I want to fit it so my number sentence is easy for you guys to read. So we're going to just make these smaller. So 2, 3, 4, 5. Alright, guys. I needed to be able to fit a lot of them. So I'm just drawing a rectangle and then I'm splitting it 5 times so I can get 6 faces. And I did that 2 times so I can have 12 spaces. So that's what we're going for. So I'm going to do that 3 more times. Alright, so I'm drawing my last one for my fraction. I just drew a big rectangle. I split that in half, and then I am going to go down vertically 5 times. That's 2, that's 3, that's 4, and here's 5. So now all of those are split up into 12s. So now we're going to identify our holes. And again, holes just means that they are all shaded in. So guys, all shaded in means we have 12 total parts and 12 shaded in. Added, we're going to just do the same thing. I want you guys to see. But I'm not going to do it exactly at the 4 because that would mean 4 of these, right? So we got that from the last ones we're doing. So I'm just going to go ahead, since it's our last one and we worked really hard to get here, we're just going to go in and figure out different ways to make this. So I'm not going to make 4 whole ones because we already know that's the easy way. So I'm going to make maybe 2 whole ones. So this one will be whole also. Therefore, the fraction should be 12 over 12. All right? So now that we have 12 over 12, I'm actually probably going to have to draw me another one. And I split that in half, and now I'm going to go down 2, 3, 4, and 5. All right, so now we have that. And so now I'm going to shade the top portion. And that will be 6 of these. So this will be 6 over 12. Then this one, I'm going to shade the top. And I'm going to do 4 from the bottom. And that's going to give me 10. Because these are 6 and that's 4. So that's 10. So now that I have that, I'm going to then go ahead and do these half up here. For another 6 over 12. I'm going to add that in. Alright, and then for this last one, I'm going to do 6 again up top. And then 3 at the bottom. For a total of 9 over 12. Got over a little bit, so we have room for our answer. Alright guys, and so now we're going to see, does this work out to be a way that we can decompose 4 and 7 over 12? So how do we do that? We do that by setting our denominator. As always, circling our numerators, which creates our sentence to let us know what we need to get as a numerator. So now, we have 12. So again, practice, practice, practice your multiplication. And so we have one 12 and we have another 12. That is the same as saying 12 plus 12 is the same as saying 12 times 2. Now, you may or may not know, but 12 times 2 will give you 24. Practice, practice, practice your multiplication. So now that we have 12 plus 12, 24. We are at 24. So now we're just going to count all together, guys. From 24, we're going to add 6 more to it. So let's go.
25, 26, 27, 28, 29, 30.
Alright, so we're at 30 once we added that in. So now, if you know how to count by tens, and you're at 30, and we're going to add another 10, all we need to do is now be at where?
40.
There we go. Great job. So now that we're at 40, we're just going to add up 6 more times. So we're at 40. Let's count up 6 times. 41, 42, 43, 44, 45, 46. Now we're at 46, right? So, lastly, we just need to count from 46. We just need to count up 9 times. So we have 46. Let's count. 47, 48,
49, 50, 51, 52, 53, 54, 55.
55. That's what we got. 55. And we can see that's a real big number on top of 12, which is an improper fraction. So we're going to quickly put that 55 down into our house. Put our 12 out on the outside. And again, guys, multiplication. So now we need to find out how many groups does it take of 12 to get to 55. Well, we already know 2 groups takes 24, right? So how do we get to find out the rest? 12 times 3. So what will we do, Jamir? 12 times 3, we need to count in or count up 12 times, right? That's how that would be an easy way for you to find it. So let's all count together till we get to the next 12 after 24. So we're at 24. 25, 26,
27, 28, 29, 30, 31, 32, 33, 34, 35, 36.
36. So 12 times 3 will get you 36. It's 36 is not close enough to get to 55, so we need to see what 12 times 4 would get us. And the same thing. All we need to do is just count up 12 times from 36. So let's go. 37,
38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48.
All right, we're at 48. Now, 48 is really close to 55, but just to double check, since you guys don't know your multiplication, we need to see. But if you know your multiplication, then you would already know. So, we're going to go count so we can all see together to see how many groups we need. So we're at 48. We're going to count up again 12 more times.
49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60.
All right, great job. So we are at 60. 12 times 5 gives you 60. So if you knew that ahead of time, then you would have known that that would have been too much because we go past 55. So with that being said, we need to use the 4 because it doesn't. So we're going to put our 4 over top our second 5. We're going to do the multiplication. 12 times 4 is how much?
48.
All right, so we put that 48 up underneath our 55, our subtraction, and our equal. Now we're at 48. We're just going to count up to 55. 40.
49, 50, 51, 52, 53, 54, 55. 7.
All right, great job. So now we get a 7 as a remainder. The 7 becomes our numerator, and 12 is our denominator, which matches the number we started out with, which is 4 and 7 over 12. All right, guys, so I've already drawn my 12s. So we are just going to label them. This is 12 over 12 plus 6 over 12 plus 6 over 12 plus 10 over 12 plus 11 over 12 plus 10 over 12. So we're going to do the same thing. We're going to set our denominators and we are going to circle our numerators. And we're going to get to adding. So we add 12, we're going to count up to 6.
13, 14, 15, 16, 17, 18.
All right, we're at 18, we're going to count up another 6.
19, 20, 21, 22, 23, 24.
All right, so we're at 24. Now we're going to jump up a 10. That's just going from the 20s to the 30s, right? So now we have 24, then we have 34. So we're at 34. We're going to count up. I don't want to confuse y'all because y'all watching, so y'all didn't see. So that's not fair. So we at 24 here. We want to add our 10. So we have 4 plus 0 is how much? 4. And 2 plus 1 is how much? 3. That's how we got to 34. I don't want anyone to not know what's happening. So, now that we're at 34, we need to add in this 11. So we have 34. We're going to add in 11. So we have 4. We're going to add 1. From 4, we're at 5. Great job. And then we add 3. We're going to add 1 more, so we should be where? We're at 3. We got to add 1 more. That's
4.
it. Exactly. So now we're at 4. So we have 45 after adding that. So now it should be easy to add that last 10, right? So if we're at 45, we only need to add a 10, which means the 10s is moving up. So you could do it in your head. 45, we have 1s and we have our 10s, right? We're adding a 10. We're not adding any 1s because this is the same thing, 10s and 1s. There's 0 1s, but there's 1 10 that we want to add into our already 45. So that just means our 10s is just going to go up 1 time. Our 1s didn't do anything, so we need to keep our 5. So in our new answer, it would still have a 5 in the 1s because the 5 is not changing. The 1s did not change. You see that? We didn't add, we added 0 to the 5, still leaves us with 5. But if we add 1 to 4, if we add 4 and we add 1, then where are we at?
5.
Exactly. So our new answer would be 55. So we would have, again, 55 over 12. Doesn't that number sound familiar? Yes, it should. Why? We just did that. We just had 55 over 12, and we all should know now, right, without having to count up 12 times, that 12 times what do we need to be next to?
4.
Exactly. 12 times 4 is going to be the closest group. That's going to get us how much?
48.
All right, so 48 underneath the 55. Take away, we're at 48. Count up to 55.
49, 50, 51, 52, 53, 54, 55, 7.
All right, that's how we got our 7 and 7 over 12, guys. So we got another way to decompose 4 and 7 over 12. All right, guys, so that concludes the end of this video. I really hope that you got a lot out of it. We are going to now be moving out of fractions just for a while into some other areas, and I hope to see you at the next lesson. But in the meantime, please never forget, it's not about what you don't know, it's always about what you're willing to learn.